Hello students. Today we are going to talk about the versatile nature of carbon. First of all, let us know the meaning of this versatile word. In general, it refers to something that is capable of being used for a variety of different functions or activities. Also in chemistry, a versatile element is one that performs many functions at a time or forms various kinds of bonds at the same time. On the same lines, can we call carbon a versatile element? Let's answer this. At the beginning of this chapter, we talked about the myriad of compounds that carbon forms and that we use in our daily lives. The number of carbon compounds whose formulae are known to chemists is in the millions. And do you know, this outnumbers the compounds formed by all other elements put together. In fact, we are also made up of many such carbon compounds. So, can you think of functions that carbon performs? Also, think about types and number of bonds that are made to form these compounds. This is why carbon is such a versatile element. But why is that this property is seen only in carbon and no other element? Catenation and tetravalency are the distinctive features of carbon that make it incredibly versatile. So, what is this catenation and tetravalency? We have already learned about them previously. But today, let us know them in terms of carbon. Let us first talk about catenation. As you know, the tendency of one carbon atom to bond with its other carbon atoms, forming rings and chains, is called catenation. Thus, carbon has the unique ability to form a large number of bonds with other carbon atoms and form exceptionally long chains. But the question is, why are we saying that carbon bonds uniquely and shows catenation different from other elements? We know that there are other elements that also have this kind of bonding property with the atoms of their own type. But how long is the chain formed by them? A few atoms long. That's right. But when we talk about carbon chains, they are extremely long. Long here literally means hundreds and thousands of atoms bond together. This is because it can form infinitely large number of covalent bonds with other carbon atoms and form a myriad of compounds. These compounds may have long chains of carbon, branched chains, or even rings of carbon atoms. In addition, carbon atoms may be linked to other carbon atoms by single, double, or triple bonds. And one of the reasons for this is the small size of carbon atom. Due to this, its nucleus attracts the shared pair of electrons very strongly. Thus, carbon-carbon bonds are very strong and stable. Also, it forms bond with other large atoms very easily and fits in well due to its small size. While other elements like silicon also have 4 valence electrons, but they cannot form long chains like carbon. This is because their atomic size is so large that the nucleus cannot hold the pair of shared electrons tightly. Thus, the bonds formed between them are weak and the chains formed by them are unstable. Thus, the small size of carbon atom and the strong carbon-carbon bonds enable it to have extremely high catenation power and form a large number of compounds. In addition to this, it forms such stable bonds with other elements also. And how does this happen? Let us know how and why carbon bonds with other elements. It is because of its tetravalency. That's right. This is another special feature of carbon. Tetra means 4 and valency means ability to combine. That is, it has maximum of 4 electrons that can be shared to form bonds. We can see these 4 electrons in its outermost orbit and we can show them like this. As we know, the valency of carbon atom is 4. It is therefore capable of bonding with 4 other atoms of carbon or atoms of many other elements. But why can only carbon form a large number of compounds with other elements? Why can't other elements like oxygen, sulfur, nitrogen, etc. make such compounds? Again, this is due to small size of carbon, which enables its nucleus to hold on to the shared pair of electrons strongly. And thus the bonds formed by elements with carbon are much stronger and stable, while the bonds formed by elements having bigger atomic size are much weaker and unstable. So carbon is capable of bonding with 4 other carbons or some other monovalent atoms or divalent or trivalent atoms. For example, carbon bonds with 4 hydrogen atoms. That is, we have a methane molecule. Now if we replace any one of these 4 hydrogens with chlorine, we get a new molecule with new properties. Similarly, if we replace another hydrogen with chlorine as well, we get a new molecule with 2 hydrogens and 2 chlorines now. This will also have a different chemical properties, isn't it? Yes. And now, if we are to replace all 4 hydrogens with chlorine, the new molecule to be formed is carbon tetrachloride, that is CCl4, has a completely different properties. Observe that new molecules found here every time have different properties from methane, the original compound. For example, we had methane, which is commonly used as fuel. But when 4 chlorine atoms are joined instead of hydrogen, the new compound formed, that is CCl4, is commonly used as a cleaning agent because of its changed properties. Thus, not only chlorine and hydrogen are the ones to form compounds with carbon, but almost all elements combine with carbon to form huge variety of compounds. Metals like sodium, potassium, calcium, iron, etc. Non-metals like fluorine, chlorine, bromine, iodine, sulfur, etc. And metalloids like boron and silicon form bonds with carbon. And new compounds with specific properties are formed. In simple words, the specific properties of new compounds depend on the element attached to the carbon. So now you have the answer to your question. Why is carbon so versatile and other elements like oxygen, sulfur, nitrogen, etc. are not? Due to this versatile nature of carbon, it can form numerous compounds. But how are these compounds formed? Is there only a single covalent bond in these compounds? Or are there double or triple bonds as well? Think about it. See you in the next video.